to get started, I wanted to know if anybody has had any prior experience working with graph databases at all to get an idea. Okay, so it's sounds like for the most part we're all new to this, and I will say I'll preface this with saying this is brand new to me, so I hadn't used this at all before um, prior to preparing for this presentation. So the motivation behind this is my family, particularly my uncle's been capturing trying to capture our genealogical family tree for, go off cam, for the past like 30 years or so. And so he's collected all this data, and I thought it'd be interesting to be able to, one, make sure that gets preserved, and two, like see what other information we could realize from that data, and what other and ways we could interact with that data. Uh, so I can't remember who, but someone put me onto this graph databases, and so that is the motivation for why I chose to talk on this topic. All right, I will share. Let me know when you can see my screen. Think it's up.
Yes.
All right, so what is a graph database? So I'm going to be reading a little bit. Like I said, this is new to me as well. So I'll read and then we can discuss. But a graph database is a type of NoSQL database that models data in a graph format using nodes. Well, nodes are like the entities in a relational database, and edges. The edges are relationships. And those nodes and edges can have properties. Unlike traditional relational databases using tables, the graph databases are designed to highlight relationships between data points. So in graph databases, you actually will save the relationships between nodes themselves, making them ideal for complex queries and analysis where connections between the entities are important. So Ben and I were discussing, and I was thinking about, like, as I was doing this, why choose a graph database? Like, what is the benefit of using that over a traditional relational database or no document or a document database? Um, and the main benefits are highlighted here. Again, I kind of touched on it before, but the relationship handling. So in graph databases, the relationships are first-class citizens, and they're stored at the individual record level. They're also, the relationships themselves are not computed at query time, so this makes it more performant, and so traversing the nodes is much faster than navigating the joins in a relational database. Uh, Graph databases are schemaless, so you can add new types and relationships or properties to your graph without having to regression your existing data there in like an RDBMS system. And the performance benefits from having not having to, so in graph databases, nodes connect to other nodes directly via pointers versus using indexes in a relational database management system. So because of that, because they have direct access to other nodes, they can traverse millions of connections per second. So the ability to provide real-time insights by leveraging all the things that I talked about before, this makes it really good for displaying or aggregating real-time data and realizing value from it. Some examples would be like, consider a social networking application. What if you had to find all the friends or friends of friends in a social network that would require you to join on 3 tables roughly? which could be slow, having to navigate those joins. In a graph database, the operations are fast because the relationships between the users are stored as the direct connections. So here's an example of a relational database schema. And so now I'll ask you guys to kind of study it for like, yeah.
Maybe can you bump the font a bit so we can see?
That good?
Yeah, thank you.
So you have orders, you have, that have a relationship to customers, and the orders relate to the products through these order details. So as you gain additional, so as you get more products, this order details table is going to grow immensely, and you're going to have, it's going to slow down your queries the more that this grows. I can even go here and it talks about this in detail. Or it would if I was signed in. But here, just study that, because I'm going to ask some questions here. So try to study this for a second, and then we'll get to those questions. Okay, I'm not going to be able to quickly find the link here. So given this schema, how would we find all the customers who had ordered a specific product? Whoever wants to take a stab at that, or just give it, doesn't have to be an exact, concise answer, but does anybody want to take a stab at that? All right, so
there's a question in the queue. Usam, you can go ahead.
Okay, so maybe join both of the tables of the product and customers, and then filter that specific like product.
yeah, so you would have to do joins between, I think, the orders, the products through the order and the order details and the customer in order to realize that. And here's an example query. So you select the customer, and if you wanted the customer and the company name, you'd have to join on the orders, products, and match for a specific product. In Neil for J's cipher, this is kind of how you would accomplish the same thing. Well, first I'll show you how it would be structured. So we'll get to cipher later on, but you can see here you have a customer node, and it has a customer ID and company name. You have a product with that ID. You have an order, and then you create the relationships. So you can reference these. I don't know if they're called variables or not, but they're essentially variables. So you can reference these later on and create the relationships between those. So given that we would have that in place, this is how you could return the product for a specific customer. So you would say match on, so this is the node, match on the order that was placed, and it contains a specific product. So you could match on the product name or product ID here, and you return, this just returns the company name. So you could return the customer name here as well. So hopefully that gives you some insight into where this one match with index without indexes joining on these, I don't want to say join, traversing these relationships in order to return the correct result. There are more examples here. I'll go over this last one quick. So how would we find, given this schema again, clear this up. And Ben, you can keep me honest on time because last time I did not do great with that. But so given this schema, how would we find all the customers who had ordered more than 5 products?
I'll take a stab at it. I would be joining the customers on orders, and I'd be doing a count command with a having, because you can't reference an aggregate in a where clause, but you can't have a group by with having.
Yeah, I think this is very similar to what you're
Yes, exactly.
suggesting. Yeah, so you have the customers and you have the joins on the orders details, grouping by the customer ID and company name where the count is greater than 5. In Cypher, this is what the query would look like. So you would match on customer that's placed in order that contains product with count as product count, where the product count, and you have to do a distinct on the count, I guess, or on the product, sorry, where the product is greater than 5, product count is greater than 5. So why it's easier, for Jay, the direct relationships, you can directly express relationships between entities like the customers, orders, and products without needing to worry about complex joins. The queries are simplified. So once you get familiar with the syntax of Cypher, it is rather like expressive what it's trying to do. You're speaking more naturally about the queries. They read naturally. But yeah, so this speaks to that too. The graph structure naturally represents the relationships. So and I talked about the index-free adjacency, not having to store indexes to other entities and just having relate pointers to the entities that they relate to themselves speeds up the query time dramatically. Some some use cases might be recommendation engines because they can analyze user behavior and recommend products or content on patterns of similarity. So this is like analyzing tons of data quickly, right? And relationships, fraud detection, and knowledge graphs. So I haven't worked in any 3 of these use cases, so I'm not able to speak to them, but here's some use cases for graph databases. Also, like, social networking. So I went over, so we can come back to some of these examples. I actually hope to find better examples than these, but I would like to dig into like some more information here. So the elements of a graph. So we have the node, which is or a vertice, which represent entities such as people, products, concepts. Throughout this, for the next few examples, I'm going to be using an authors and books schema. So this might be an author, or a book would be a node. An edge would be like a relationship. So the edges or relationships represent the connections between the nodes. For instance, like an author might have written a book, or an author might have published a book, or a book might have won an award. So that is an example of some relationships. And then labels. So the node itself would have a label of like book. It's pretty much the name of the node, or the name of the relationship. They're also like the handles into how you grab the nodes or reference the nodes in Cypher query language. And nodes and relationships also can have properties. So I found it interesting that, so not only can the nodes have properties, but the relationships themselves can have properties as well, which we'll get into in the next section here. Does anybody have any questions so far? Okay, now we'll get into directed and undirected graphs. So an undirected graph would be like, you could have a book can relate to an author, and an author can relate to a book. So they can go both ways. Like a book could have been, you could navigate from a book to an author, and an author to a book. Whereas with like with a hierarchical relationship, like a parent to child, you could in theory navigate the other way, but to keep that hierarchy, you're having a direction, or a directed relationship. So I'll just read a section on here. So in a directed graph, edges have a direction indicating a one-way relationship between nodes. Traversal in a graph involves moving from one node to another along these directed edges. In contrast, an undirected graph does not have a direction associated with its edges. In an undirected graph, it allows movement between nodes in both directions. And so I had talked before about how the relationships themselves can have properties. So here we have a love property on this. We have a love relationship, and it has a strength property. So you can weight, basically it's weighting how much love they have for one another. So when you think about this in combination of being able to traverse, so in this case, the property of the has road relationship is the distance. So you could, in theory, use the weight of the relationships to determine the short amount of distance to get to one node to another. So to get from Springfield to Centerville, what is the shortest amount of travel? So I just kind of talked about weights. All right, so we talked about, well, go ahead.
I was gonna say that this is very neat, like having properties on the relationship, because it's closer to how we think about the problem. I think, you know, the example you were just showing with the distance as a property to the relationship.
Yeah.
You know, so I was just gonna say that it's very neat. Again.
Yeah, I'm sure we could find a lot more use cases for that, and where that would come in handy. Okay, so Neo4j. So Neo4j is a graph database. These are just highlighting basically what we've talked about. Emphasis on relationships, graph databases, or NoSQL databases. They're schemaless, and they leverage this. Neo4j leverages the Cypher query language that we have seen. It's got good performance, capable of traversing millions of relationships per second. So, yeah, so Neo4j is the graph database that I chose to experiment with. There are several ways to get started with Neo4j. They offer a fully managed cloud service. So if we go here, I already have an instance set up. So you can have one instance for free. And then I think, yeah, additional instances are like 60, I don't know how many. Yeah, so like $65 for another instance. All right. And I don't know about, like, I'm sure that's not a flat rate or anything like that. I'm not sure about pricing. I didn't look into that. But here you can open up the instance and you get this nice interface. And what I liked about this is you can generate queries. So I can show you how to import data. I've already imported some authors. So I can import another scheme, another node. So go here to add a node. Ooh. Add a node, and then here I can give it a label. I'll call this books. I'll select a file here, so you can create your schema based on like in CSV here. Let me open it up to show you what it looks like. So it's just a simple CSV with a book, a title, a publication year, an ISBN number, and a genre. So you can map your properties here from the file. So here I want to take all the properties and confirm, and then now I can select run it. Oh, it looks like it's not finding my files anymore. So I gotta go back in here, relink the files. Okay, let's try that again. So now it's running the import. So it ran the authors again, where we can explore the results. Right now, I don't have any relationships, so it's not very interesting, but you should be able to match. So I can just return all authors, or let's do books. So here I'm just saying match basically all books and return all the books. So here you can look at it in this view where you can click on the node. It's probably really small. You can click on the nodes and see them. You can look at it in a table view. You can look at, I don't know what this shows you. There's probably way more, so like I said here, I could say, give me all the books that contain Harry Potter in the name. This should generate a query for me. Yeah, so match books where the title contains Harry Potter. Boom, you know, all the Harry Potter books. So that's what I liked about this is getting used to the language. I could generate queries using the prompt there. So that one's available. There's also Neo4j desktop. So get started, you'll download the the installer, you'll install it, and then you'll be presented with an example project that will have a movies database already loaded for you. But what you can essentially do is you can create a new project if you want, and then within this project, you can add a local DBMS, give it your password. I already have one created. So in here, I have two databases, a books database and a Neo4j default. This Neo4j default will come. So when you'll have a system in a Neo4j by default.
Hey, Derek, you have a question. John, go ahead.
Yeah.
Thank you. Back to your import you did. Is the import command you ran on the UI, does it do a truncate first, or does it do an append? In other words, if I run it multiple times, will I have multiple versions of the same data?
I think you have multiple versions of the same data, but you can create unique constraints. I just haven't done that. So you know, I could say I don't want to have a book with this, you know, author and title. I think you can create unique constraints like that.
Oh, is that like a primary key or a unique key on the object, on the node?
I think I have an example. So here's an example of like setting a constraint on the person ID.
Brilliant. That's what I was looking for. Thank you.
Yeah, absolutely. So the Neo4j desktop, back up. Thanks for letting me know I have questions. I'm not going to be able to see those, I can tell. So yeah, you can open this up, and then you can connect. When you connect, you'll be able to enter in your queries here. I think I have data already loaded. Yeah, so here I could. So this will return all the authors that and the books that they wrote. It will return the author's name, the title of the book, and publication year as the publication date. You can see here's all the books that are returned. Here's the text. I don't know why it's not giving me a graph. Usually there's like a graph view. I have not exhausted all of the capabilities with this tool by any means. There's plenty of guides here. There's example graphs and example queries. This is how you would switch between your databases. You can select here and see all, well, here's the graph. You can see all the nodes. You can select the relationships and you can see the relationships. So these books belong to this series. See who wrote these. Authors wrote these books. So that's the Neo4j desktop. They offer a Neo4j browser version, which is a lightweight version, so you can connect to your local instance of Neo4j from the desktop, from the browser, sorry. It's the browser UI looks identical to the desktop version. And then you can also, oh, do we have a question? All right. You can also use Docker, so you can set up a Docker container and load data into that. Ashil helped us with this, so we'll see this set up and how you can load data into it. Here's an example of the a Docker compose file. So we're just giving it. I can't remember what these ports are for. One's the inbound, one's outbound, I think, and then you know, password. And this is kind of an important thing. So there's a load CSV function in that the Cypher query language uses to import data, and it looks by default into a specific directory that's configured in Neo4j. So you need to import your data in that and mount your data in that directory. All right. So now, is there any questions about getting started with it?
I typed a question in the chat. Summary at the end, and then it has an AI map that it gives you as well. And the critical blank is where the optimization service different. Critical blank around the flaws.
Snowflake, you will have time at the end of the talk to ask a question about a database person. Is that okay?
Okay. It doesn't look like a question. All right. So the basics of Cypher query language. So Cypher is the query language that's used by Neo4j. The basic structure of a Cypher query is so you use this match keyword to specify the pattern of nodes and relationships to match in the graph. You have the nodes and the relationships here. So here I'm referencing a node, giving it, I'm going to say variable for lack of better, say here, nodes. Yeah, so this is like a reference or a variable to this node, the relationship, and then the other node that it's relating to, and then what you're returning and the properties off of those nodes. So in this example, yeah, I don't think I need to walk through that. You're matching all of the, you're returning all the records that match this relationship between these nodes. So for finding a specific author, like you match, you give the node, and then here's how you reference a property within that node. Use curly brackets, property, and then the value, and then the relationship. Here we're using a directed query. We're referencing a directed relationship because the arrow is saying the author wrote the book. If it was this way, which wouldn't make sense, it would say the book wrote the author. And then you're returning the title, the publication year, and the genre. Here we're how you create a node. So you use the create keyword. You're giving it the type of node that you want to create. You're setting the properties. Creating a relationship. So you're matching a specific author and a specific book. And you're saying create this relationship, the wrote relationship between those nodes. And here you're getting a weight, you're weighting it saying that this author contributed 100% to that writing of that book. Updating properties, you can match on a specific book and then set this genre property to fantasy here. So here's updating a property. You can merge. So this is pretty cool. So you can say, I want to merge on this book. If the book isn't created, I want to create it and set these properties. Otherwise, I want to match it and set these properties. So it's like a save. And then deleting data, matching for a specific author. Oh, here it's matching. We're deleting this relationship, the rote relationship. And here we're deleting a node. All right, so now for importing data, here's that load CSV command or function that I had mentioned before. So here you load CSV, and you say you can say with headers from then the path to your file. Like I had mentioned before, it's looking in that import directory by default. So this must be the path to the import directory, and then or like from the import directory to the file. So here we're saying load each of these as rows and create. So this would be the name of the node, the property, and then you're mapping it to those columns. And here are some real examples. So here we're loading series, authors, books, the relationships between the authors and the books, and the relationships between the series and the books. So here we got the node, the properties, the row, we're referencing the row, and then the property, the column in that row. Same with loading person data. All right, is there any questions regarding Cypher specifically, or anything that we've covered so far?
Yeah, I just wanted to make a small remark to what you just showed, how to load the data. So I think it was yesterday, it dawned on me that the path to the CSV file can actually be a mounted path. Like for example, in the case of a Docker container, so if someone wanted to run Neo4j as a Docker container, it's definitely possible to mount the path to the, yeah, exactly like that. Yeah. So it's one option to do that. And basically from inside the dashboard for querying, then like you just showed, the Neo4j should be able to find those files and load them.
I have a quick question. Derek, have you had a chance to try out retrieving your CSV files from, say, Amazon S3 storage?
I have not. Yeah, I don't know if that, Ben, do you have something to speak on for that, or?
Yeah, I mean,
No. Oh, I'm sorry. Go ahead.
Yeah, go ahead. Go finish.
No, I'm just going to qualify that we have a lot of clients that use Google Cloud or Azure and AWS for storage. And I didn't know if there was any issues or things to be aware of.
Okay, yeah, no, I haven't had experience with that. Okay, so
But I believe if Neo4j, I think Derek, you mentioned that there's a Neo4j for the cloud, right? If I'm not mistaken.
for the like
Like
as
a cloud
service,
version, like a cloud version of, yeah.
There's like a SaaS
Right.
version.
Right. So typically what I've seen is that, if you have a SaaS version of a particular tool, the storage, where the storage is located, it can be flexible. It's just a matter of, that particular company allowing you to access another storage service. But so I don't think it should be a problem, but it warrants checking, I guess.
Yeah, but I think also for I mean, if someone is not using the SaaS version and they wanting to load it, it's still possible to do it. I forgot, I can't think of the name right now, but there are some tools that can act as a file system, but actually be backed by cloud
S3.
storage like S3 and so on.
Yep.
So the same technique I was just mentioning with Docker could be used to just mount the storage. So,
All right. So now I'll dive into like how to leverage Neo4j in a web application. So in this demo, this first one, we're gonna show building just a simple application that can display books, the authors of those books in the series that those books belong to visually. So we're going to be using this Python, FastHTML, Neo4j, and D3. I'm sure that you're all familiar, but Python is a high-level interpreted programming language. It's particularly well suited for data visualizations, for its accessible syntax, extensive libraries, and community support. It's highly supported in the data science community. And HTMX is a modern HTML first Ajax library. So HTMX allows you to get around some of the bottlenecks of HTML and hypermedia, like having to reload the entire document when submitting forms and etc. So you can leverage it. It uses HTML attributes to hook into JavaScript to, like, say, reload parts of pages that are, you can target individual divs and things, and kind of swap out their values using HTML events or DOM events. Sorry. So here's a basic example. Like, you could have a div, have some initial content in every 5 seconds. It would trigger a call to this endpoint to retrieve the data from this endpoint and replace the content of this div. And here's like here's the endpoint that it's calling for the updated content. FastHTML. This, Ben introduced me to this, and I joked with him where I said I might have been more excited about this than the graph databases, because I had never messed with this before. But it was once I got over the initial frustrations of trying to like not do what I was doing previous. Like, there's a lot of things that this will do for you out of the box that I didn't realize that I was trying to do, and I ended up fighting it. But once I embraced it, it was nice to work with. But FastHTML is a Python library that provides a way to generate HTML content. It's built on top of FastAPI, and it also leverages HTMX. It's simple. It integrates with FastAPI well. It has dynamic content generation, and it has a component-based structure, so you can create reusable HTML components in Python and use them across your applications. So here's an example. Pretty much all you would need to have a page going. An H1 and a paragraph tag, and you just call serve. Now, I don't know what I'm not as familiar with what all this is doing behind the scenes, and it might reach for Ben. If you know, do you remember what this is all like, some of the things this is doing behind the scenes?
yeah, it just configures because like the low level Python server that it's using, or at least server library or server framework that it's using, is called Starlet. you know, so all of the wiring configuration and all that stuff happens in this function. Like, I mean, anyone interested can look at the signature of that function and will notice that there's a lot of defaults. Like, for example, the HTMX JavaScript library that's automatically loaded on the page, you know, is set up by default by this function. By default, it's also using, I think, Pico CSS. It's all pre-configured in there. And then this one gives you an option to override the defaults and place your own, right? So after it's done the wiring, it returns a tuple for which the first value is the app, okay? And the app is the one that can be used to spin up run the application. And then the route, this is a helper function to define the different routes to the different pages of the app you're building. And that's pretty much it. Basically, it reduces a lot of boilerplate code that you will have had to do yourself and just focus on building your app instead. Yeah, that's it.
So we'll be use that and then D3. So I had never used D3 before, but so D3 stands for data driven documents. It allows you to build it's very flexible, so it allows you to really have control over how your graphs are built and the interactions that you have with them. They're all data driven, follow web standards. For me, it was a matter of working with a language model that could kind of help me do what I wanted to do in D3, as I wasn't familiar with it and didn't take the time to master it. But here's a basic example of how you could use your data. You set the scaling, and then you're selecting, where you're going to render your chart, and appending your data to it and setting the width of the elements. All right, so for this demo, this was all the folder structure, the setup that was needed. This is used Rye in this application. So we have a database connection. We have the main file that includes the endpoints, the FastHTML setup basically, and the logic to retrieve the data, and then there's a D3 JavaScript file that contains the D3 code that is served from this main application. So here's how you would start it up. I'll jump to the application. So first I'll show you, and then I'll explain the code. Okay. So here we have a chart or a graph, and on the inside are the different authors. So here's all the different authors that we have loaded. And on the outside are the series that they've contributed to. So if I click on an author, I can drill down further, and I can see this author, all these series. If you see standalone, it's like not a part of the series. And if you notice inconsistencies or inaccuracies with this data, it's just for demo purposes. So you can click out, and or when you click the center, it goes up a level. So I can also see, if I wanted to see what books are in this series, I could click in there. So it's a nice interactive chart. Any questions about this? All right, I will go to the code.
Yeah, is it possible to bump the font?
Yeah,
That's really funny.
yeah, I should have done this ahead of time. It's funny because like I don't use PyCharm that much in the when I went to open it for this presentation, I noticed like everything was huge. It was from the last time I did this.
Yeah, I think
You know,
you can just do Command plus.
it doesn't work
Oh,
here. I can't remember what we did last time. Here, presentation mode. Okay, so this is the database.py file. So here we're basically getting the Neo4j database driver, or wait, yeah, we're returning the driver here, passing in our credentials. And there's two versions, the synchronous and asynchronous drivers, and then we have some query functions that are synchronous or asynchronous. Sure that stuff is what, so it's just basically leveraging this execute query function, passing it the driver and the query. We go to the books.py file. So here's where most of the action is happening. So you'll see here we have our query. So we're matching on all the authors that wrote the books. There's an optional match on retrieving the series that those books belong to. So we're returning the name of the author, the book, and the series. I think Ben, so this route is exposed. This exposes all the static assets in the public directory of the root project, making it able to load style sheets and inject JavaScript from that folder. So this is the request to get the graph data. So when we retrieve this is basically just formatting it in the structure that we would like to serve that chart. And then here is the FastHTML code. So here we have the title. We're linking our style sheets. I'm very happy that Ben helped me with this because I was really struggling to get style sheets linked and reference the JavaScript file. So this is how you would reference your style sheets, and then have a nav bar, and then here's what the div we're targeting to load the graph. And you can see here we're including D3 and the graph. Then I will show the graph just for completeness sake, but this was heavily, I worked with, I had assistants, so I'm not sure exactly everything this is doing, but this is the code for that is displaying the graph and rendering it and doing the animations. And then I can show how the data was loaded. So once you start the Docker container, or you have your instance of Neo4j, we have this Python file that will load the CSVs that are mounted into the container, or in the container. It will load the data into the Neo4j instance. So here we're setting up a connection, and then there's this load CSV to Neo4j. So we give it the path. And this is actually referencing files outside of the container, so it doesn't look like it needs to reference files that are in the import that volume. But anyway, it's giving a reference to the series, and then we're creating that node and mapping the columns to these properties. Same for all the rest of the files here. So I can switch quickly to use this instance. So I will just a moment. I'll stop. So I'll stop Neo4j desktop. I have to change some properties. Second. Okay. And then oh, okay, I'll start up the Docker container. Oh, 1 second. I never got the service working for the web app. And actually, I'll start this an interesting way. Some people might know you can do this, and I'm interested if there's another way of doing this. I'm sure you can do this from the command line, but I'd like to start to interact with this compose file and just start this service and not this one instead of all of them. I'm sure that there's a way to do it from the command line. I always go into Visual Studio Code, and this is typically when I have a Docker compose file that has, like, 6, 7, 8 services. You can go compose up and select your services. And then here I can say, I just want to do the graph database. And here's probably how you would do that. So up -D build, and then that service. Okay, so now you can access this from the browser. So this is that browser version of Neo4j. Let's see if I have data in here or not. I do. So I'm going to delete delete all the data. I think you can do that by saying delete and can't remember how to do it. Match. I'll have to look it up. Yeah.
Is it possible to bump the font again?
Yeah. 1 second.
Yeah, thanks.
Okay, so you got to do match. And since we want to delete everything, delete that. Oh, you got to delete. Yeah, delete relationships. Okay. Okay. So I was missing a keyword. So because I tried to delete all nodes and they had relationships, I need to match on the nodes, detach them, and then delete them. Okay, so now there's no data in here. So let's see if we can use that load data script. All right, so we have an error. I think I know the issue. I think it's connections. So right now I just tried to connect and load that data and it failed because it couldn't connect. I'm just checking that my my properties are correct. Yeah, the port was wrong. Okay, so now it's loading. It loaded all the data from the CSVs. Now we can see the authors, books, person, series available here. So that's an alternative way to start an instance and load the data. All right. So the next thing I wanted to show is an example of a family tree. So this was kind of the main thing I wanted to work on. And I will say that I had the biggest challenge I had was actually visualizing visualizing the relationships of the family tree and getting the schema correct in order to do so. And I have I haven't completed it. So it's not a I wouldn't say it's a solid implementation of like displaying a family tree, but it is still worth looking at. It's already running. Okay. Okay. Sorry for the interruptions. My Docker instance uses a different port than the desktop version, so I had to switch my configuration around. Okay, so if we look here, we'll see a family tree. So what I was mentioning about it not being like a good representation or accurate there's relationships in here that aren't captured. Like for instance, I think Martha and Thomas are married and they have, so if I click on Thomas, you can see his child is David. If I click on Martha, her child is David as well. So we would want to have a relationship between Thomas and Martha and map the children to that relationship rather than to the parents themselves. And that's what I'm going to try and what I would do differently. I just didn't get it done in time in order to present. But I still think this is a cool visualization. So what you can do here is as I've shown, you can like click on the individual nodes and kind of traverse this tree one by one. And you can do it that way. Otherwise, there's an expand all button here that will expand and show you the entire tree. See, look, you can see William, Michael. This this section of the tree is identical to this this section of the tree. So some room for improvement, but it is cool. You can scroll over here and you can see a little tooltip to help you navigate this. You can zoom with the scroll wheel and zoom out, and then you can collapse all. All right. So I'll show you the code for that. It's pretty similar to the other example. So here we're retrieving all the people and uh, their children, and then formatting the data here in such a way that we can again represent them in the visualization, and then same an endpoint to retrieve that data. And then here is very similar to the other example, the setup for the HTML. Uh, nothing here is different besides like the text pretty much than and this interactive uh, tooltip help, just info box. And here I have here's the expand all button and the collapse all button. Similarly, here's the D3 visualization, setting up the ratio or the width of the container, actually setting up this SVG container, and then kind of adding the interactive behavior and drawing the nodes. All right. I think the next steps would be like deploying these applications, which I haven't gotten to. But that's pretty much it. And Ben, I can hand it over to you to go over what you had planned to discuss if you're prepared for that.
Yeah. So I'll take the ball for just a second. Let me share the screen. That's my ID. Okay. Okay, so is my screen visible to everyone?
I can see it.
Okay. Yeah, so so yesterday we were just discussing like to see if there's a way to facilitate the way that we query the graph database, in this case Neo4j, right? So in order to query it, we can definitely make use of a helper like an LLM, whether it's Claude or something like that, right? And then in order to actually implement something like this, it's necessary to be able to derive what the schema is. I'm not even sure if it's appropriate to say schema for like a graph database like Neo4j, but basically, if there's a way to collect some enough metadata that we can pass to the LLM, so that after so that if we join that metadata to a prompt, to request to request some data to be retrieved from the database, the LLM can help us draft those queries, and then we can use those queries to actually retrieve the data. So this is just a proof of concept. It doesn't work 100% in 100% of the cases, but this is just to give you an idea. So to reduce the boilerplate, if you inspect the Docker repo, I'm leveraging this tiny abstraction over the instructor library for Python, and then in here, this is kind of like what it looks like to use that abstraction. So what I'm doing here is that I'm just defining what I want back from the LLM, like I was just describing. So I want an object back that actually contains the query to be executed, as well as a description of the query, like a high-level description, and then some detailed explanations of what the query is going to do, right? And then here I have a system message, basically to give a role to the LLM. In this case, it's going to be a Neo4j cipher master, okay? And basically, its sole purpose is to help us, draft queries that we can execute, okay? And then again, using the abstraction, the boilerplate is hidden behind this annotation. You can look at the repo if you're interested. So the prompt annotation just takes in the system message as well as the model. In this case, I'm using Claude 3.5 Sonnet. And this abstraction, like I said, will take care of the boilerplate. And then by invoking this function, we will end up with this input object being populated for us. In which case, I can just print the description and the detailed explanation. And then it will return the query. And let me see. And then here I have a tiny CLI to help us run this process. So, like I said, we're gonna need some metadata out of the database. Okay, so I have a couple of queries here. So we are interested in these two. The first one basically collects some metadata about the node types in Neo4j. And in the second one, it retrieves some metadata regarding the relationships. Like Derek mentioned, the relationships have some properties and all that stuff. So this will be the role of that query over here. And all I'm doing then is that I'm running both queries to retrieve the nodes and the relationships. And then I extract the data and then construct a dictionary out of it. Okay, and then I'll turn this dictionary into a JSON string. And once we have that JSON string, where was I? Okay, so once we have that JSON string, then this is how I'm going to use it. So using string interpolation, at the beginning of the prompt is like this. Given the following Neo4j database schema, which is that JSON string that was extracted, generate a cipher query that matches the following natural language query. And then in this case, this is going to be our request in plain language, in plain English, right? And so this is stored into the query string. I go ahead and invoke this function that we just saw, this one that I just walked over. And then again, using the same infra that Derek showed, I'm getting a hold of the driver and execute the query and then print the result. So it's possible to do some additional work to pass the result, again, using the LLM to have a more natural response. But right now, I'm just printing the raw response from the query. Okay, so let's see it in action. So if we look at this graph, let me try to explain all. I'm gonna pick a person. Yeah, this one. I'm gonna pick Henry. By the way, quick comment. When you run this, you will notice that there is a certain direction to the graph, right? Just because of the nature of the edge. I think the edge is defined by parent of, so it implies that it points to the right. Right, so you will notice that if you ask questions that go from parents to child or grandchild and so on, the query may not return any data. However, if you ask questions that go to the right, meaning from child to parent into that direction, then you will get some data. So if we pick Henry, let's see how far we can get to get a hold of some of his great grandparents. So in here, let me zoom in a little bit. Okay, so that's the example that I was telling you, going from parent to child. Okay, so we have Michael Doe, and because here I'm asking, what are the children of Mary Doe? And if I can find Mary, I forgot where Mary is, but I can find it. But if you would inspect the graph, you will notice that this information is not correct, I don't think. Yeah, because Mary Doe is here. You know, so if since Mary Doe is basically the current generation, she doesn't have children yet. However, she has parents, right? So the information we have is incorrect in this case. So if I go and do parents of, okay. So if we take Henry, like I was saying earlier, we want to know who are the parents of 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 Henry. And then let's see what happens. So the first query you see executed here, the first two I should say, those are the queries to retrieve the metadata from the database, you know, about the nodes and the relationships. Okay, and then this is the prompt. You know, this is the text I typed, and then above it you have a JSON string. So the formatting doesn't it's not nicely done here, but you get the idea. So given the following neo for JSchema, and then it's that giant JSON string over here, who are the parents of the parents of the parents of Henry? Okay, and then and then here it's here what's printed is the high level description, and then the detailed explanation of about what the query will do. And then this is the actual query to retrieve the information. And then as a response, we have that the ancestors of Henry, like 5 level up, right? Alice Doe and Robert Doe. So let's check. Where's Henry again? Okay, Henry. And then I think, let me see. So Alice Doe and Robert Doe.
At the very end.
Yeah, so all the way at the end over here. So I think it's right. I haven't looked at it closely, but you get the idea. So that's pretty much it. Do you have any questions?
Are you willing to take a query on the fly and see if it works?
Sure, we can try.
Can you try, give me all the books? This isn't that hard. I just want to see if it'll do it. Like, give me all the books published after the year 2000 or something like. I don't know if there's if anybody has any other interesting.
Publish after the year 2000.
Yeah, or any year. Yeah. Yeah.
Okay, so we have quite a bunch. There you go. Is it correct though? Yeah, okay, so I see the years 2003, 2005, 2007. Yeah, it looks right.
Mm-hmm.
Yeah, so, and then again, this cipher query retrieves all books published after year 2000. Detailed explanation, and then it's going to explain the syntax. So, yeah, so basically the opportunity here is that if you are a newbie to graph database and cipher like me, this would be like a way to cheat a little bit, you know, to be able to leverage the value of a graph database, you know, with very low investment. And then later on, maybe deepen one's knowledge into how to use it. So yeah, that's it. Yeah, any other questions? Okay, yeah, so Derek, you can take the ball back.
Okay.
Mhm.
All right, so I had posted, so a way to get started without having to do any setup is there's this, I posted in the chat, there are a number of hosted databases from Neo4j with example data. For instance, here's like that Northwind example. Here's the movies example. So if you click here, you'll launch Neo4j browser, and then the user and password, just the name of the database. This is a read. You can only perform read-only operations. But if you look here, I'm pretty sure. So, like this example graph tutorial, like so we can walk through here. I'm pretty sure this is for the movies data set. So here's like some queries. Give me all the movies from Tom Hanks. Uh, give me all the movies. Or this is match. What is? Oh, this is the name of the variable match. This is movies with the title Cloud Atlas, returning the name of the directors. So you could go through here and play around with these examples if you wanted to in your spare time. I'm actually at the end of what I had for presenting. I don't know if we want to open it up the floor for discussion and questions. Now would be a good time.
Mhm.
I'm curious if anybody, what you guys think about graph databases. Is this something you see it could be useful, or is it just something nice to know about?
Yeah, for me, it's definitely interesting. It looks, I mean, my very first impression when I heard about graph databases was that it's very like foreign. It was really out there for me. That was true until I took a class. I think it was a data visualization class, and we were using a simple Python library. I believe, what was the name? I think it was Network X, or I forgot. But anyway, and we basically had um, to create some visualizations about how people relate to each other in a group. So that's when I started thinking that this stuff could be actually useful. I can think of a few use cases for that, right? And then I'll put it in the back burner for a few years until like pretty much the preparation for this presentation, So
Yeah.
yeah. What about you, Ashil? What do you think about the graph databases?
yeah, no, it was nice to learn about it, but I think I have some use case, but I'm still thinking about it, like, because I'm doing one project, I may think I might want to use this one, but not yet. But I have to to dive deep in to learn about it. For now, I don't have like enough knowledge, I think.
Anyone else?
To me, it's more like I feel like graph database is such a special database that not everybody has a use case for it, if that makes sense. You know, and the use and usually it's like what social media companies that probably I guess use those kind of databases. It's, I guess I'm looking at it as it's very different than like your typical relational database that, you know, like it's the use case is much bigger. So that, I mean, otherwise it's a cool. I like the visualization that can do with a Neo4j, and Neo4j has been around for so long. I actually didn't even know it was still around. I thought that it had kind of died down, but it looks like it hasn't. So it's great.
Yeah, I found it difficult to not think of it like a relational database. Like I thought I had it down, or like the fundamentals down, and then I started creating a Spring app, and I started creating the structure of the schema, and I was like, wait, I'm doing like a relational. I'm treating this like a relational database.
Yeah, exactly. Yeah, it's a different thinking, different mindset.
Well, I hope this was beneficial. I learned a lot, so it's
Yeah,
good for me. So
absolutely.
Yes, we learn a lot.
Yeah, same here. So Derek, are you going to pursue it and then build the full app out of it that you like based on your idea?
yeah, so what I'm trying to do is, like, my uncle has a genealogical narrative. So he has traced my family going back to like being related to the 9th president of the United States, and beyond that, back to the plantation where my ancestors came from. So we're trying to, my goal is to put this information out in such a way that it's like people can interact with it and gain additional insight from it, and also create like a central hub where we can link like all these, you know, family members that may want to see this information. Uh, so that's the motivation for it. So my biggest challenge right now is how do I visualize the tree? Like, I was hoping to have a nice looking hierarchical tree, and right now I'm not sure how to do that with D3 and the structure I have. So I think I need to learn more about D3 or using another using another tool, because I can't just keep asking ChatGPT to try to do what I want.
Right. Yeah, I think it's the same thing. Like, you know, even though I write a lot of JavaScript, I, like after all these years, I still barely know D3, you know, because usually when I end up with some sort of database that involves D3, it's usually through a different library, or maybe I'll do like very basic stuff, but I need to sit down and learn it properly. You know, because it's a little bit out there, because I'm more used to UI components like forms, like menus, stuff like that. Whereas for D3, it's a canvas, so it's a different way of thinking about it. It's almost like artistic in a way. So yeah, you need to learn it.
Yeah. So my next step is figuring out if there's a better tool or an easier tool or a more approachable tool, or else diving in to that, to D3, and being able to create my own visualizations, or better tweak the visualizations that the models spit out.
Yeah.
But I think having, so my plan is like, you have the parent of relationship. I think it's going to turn into like a parented child relationship. So that relationship will hold the IDs of the parents and the child or children.
Mhm.
And then, so you would have your parent nodes, and then those parent nodes would be mapped to some sort of in place node, some way to join the two parents,
Right.
a node to join the two parents, and then the children will be mapped to that node. But I couldn't, so then that, and then those children would in turn map to another, parented of node, and then have children.
Yeah. Oh, maybe you could have a node, like, I don't know what it can be called like union or something.
Yeah, parented of union. Yeah, something.
Yeah. Yeah. This is neat, like, because until today I had no idea that it was possible to add properties to the edges. So that could be a good way to capture more info for everybody involved in the family tree.
Right.
Yeah.
Yeah, like you could, like, for instance, for that union, you could put whether it was the property could be a marriage, or that or not,
Right.
because that's one of the things I struggle with, is like, not all of these are going to be result in marriage. So how do you discreetly relate nodes?
Right. Right. And also to make the graph be, I mean, not be directed towards ancestors, there could be another relationship going down, like children off or something like that.
Did you repeat that?
I was saying that currently it's the parent of. That there could be reverse also, like child of or children of or something like that.
Yeah. So you could go the other way.
Yeah. Yeah. And also, like, if you do go ahead and get deeper into D3, maybe you could implement that stuff we discussed last time. Like,
Yeah, being able to trace yourself to.
Yeah.
Yeah. I don't even know how you do that.
Yeah, like having a way to draw a path in the graph to show how one person is related to another person in the whole family tree.
Yeah.
Yeah. And then maybe, like, with all the metadata that's captured, like have an LLM like tell a good story based on the data.
Yeah. Should be interesting. I'll keep you guys in the loop.
Yeah, it's a very interesting idea, and the technology involved is also very interesting.
Part of me wants to just set my money aside and be like, hey, I need, who came in here and said they needed someone to visualize data. Maybe I need to do the same. That's the other approach I could take.
Yeah.